Welcome in the fifth section of our course. In this section, we'll be working with Spark Key Value API. So firstly, we'll start from looking at the available transformations on key value pairs. Next, we will see how to use aggregate by key method instead of the group by. In the third video, we'll be looking at the actions on key value pairs. Next, we'll be looking at the available partitioners on key value data, and we'll be implementing advanced partitioner that will be able to partition our data by the range. And this is a first video in which we will be looking at the available transformations on key value pairs. So firstly, we'll be examining available transformation of key value pairs. Next, we'll be using count by key, and also we will be wondering why this operation is not entirely safe. At the end, we will try to understand the rest of transformations available on key value pairs. So this is our well-known test in which we'll be using transformations on key value pairs. So firstly, we are creating an array of user transactions for user AB, ABC, and for some amount. Next, we need to key our data by a specific field. We are keying it by user ID, so we are invoking keyBy method with user ID parameter. Next, our data is assigned to the key variable, and we can see that type of it is of a tuple. First element is a string, that this is a user ID, and second one is user transaction. Next, let's go to the transformations that are available. So first one that we will be looking in is a count by key. Let's look at the implementation. So it is returning a map of key and long. Key is a generic type because it can be any type of key. In this example, it will be a string because here we have a type string. But in Spark, every operation that is returning map is not entirely safe. If you see a signature of method that is returning map, it is a sign for you that this data will be sent to the driver and it needs to fit into memory. If there will be too much data to fit into one driver's memory, then we will get out of memory. So be cautious when you are using this method. At the end, we are asserting that counted should contain the same elements as map B2 because we have two values for exactly the same key B. Also for 2 we have A, and C key has one value. Count by key is not memory expensive because it only stores key and counter. But if the key will be a complex and big object, like for example transaction with multiple fields, not only 2 but more, then that map could be really big. But let's start this test. Our test passed. Also, we have a combine by key method that is able to combine the same elements for the same key. Next, we have aggregate by key that is able to aggregate to different types. We have fold by key that is taking current state and value, but it needs to return the same type as the value for the key. And at the end, we have that group by key that we spoke about in the previous section, that is grouping everything by the specific key and returning the iterator of values for a key. That is very memory expensive operations as well, so we need to be careful about it.